A mysterious blue pool has just appeared in Yellowstone National Park. And it wasn't discovered quietly. This striking new feature revealed itself after what scientists are calling mildly explosive hydrothermal activity, sending shockwaves, both literal and scientific, through the region. Yellowstone is no stranger to surprises, but this time, nature seems to be writing a new chapter in its geothermal saga. Beneath the calm surface of one of America's most iconic landscapes lies a supervolcano capable of altering the planet. When even small changes begin to stir, experts and the public alike take notice. The appearance of this new thermal pool wasn't just a geological hiccup. It followed seismic rumblings and sudden changes in surface temperatures, signs that the Earth's crust was shifting, even if subtly. And when the ground shakes at Yellowstone, people start asking hard questions. Could this be a warning? A preview of something far more powerful brewing beneath? Or is it simply Yellowstone being Yellowstone, dynamic, evolving, and always unpredictable? In this video, we're diving deep into the science behind the discovery, the stunning visuals of the new blue pool, and the geological significance that has scientists on high alert. Stick around to find out what this means for the future of America's most explosive national park, and whether it brings us one step closer to understanding the sleeping supervolcano that lies below. What just happened in Yellowstone? In early July 2025, visitors to Yellowstone National Park were met with an unexpected closure near the Norris Geyser Basin. Park officials cited safety concerns due to unusual thermal activity and redirected traffic away from a remote walking trail. Just days later, the real reason came to light. A brand new, vividly blue thermal pool had emerged in an area where there was nothing before. Its formation followed a period of minor seismic activity and elevated ground temperatures, which together set the stage for what experts are calling an eruption-triggered surface transformation. This newly formed blue pool, located near the volatile Norris Geyser Basin, immediately drew attention for more than just its beauty. Its color, an intense shade of cobalt with hints of turquoise, hinted at extremely high temperatures and rich mineral composition. Measuring approximately 10 feet across and steaming at over 180 degrees Fahrenheit, the pool sits within a freshly fractured patch of geothermal soil that was previously considered stable. Its appearance was not slow or gradual. It was fast, violent, and unmistakably powerful, so much so that park surveillance drones picked up the plume of steam within hours of the activity. Norris Geyser Basin is the hottest and most dynamic region in Yellowstone. It's a place known for rapid changes, rising steam vents, and unpredictable geyser activity. This latest development only strengthens its reputation as one of the most geologically active zones on the planet. Park scientists, along with geologists from the US Geological Survey, were dispatched immediately. Their initial assessments confirmed what the visuals already suggested. This wasn't a typical shift in the geothermal landscape. The pool had formed in direct response to a sudden pressure release, likely the result of superheated water meeting subterranean gas pockets. When that kind of volatile mixture finds an exit point, the result can be explosive, even if the explosion is classified as mild on the scientific scale. As news of the discovery spread, the National Park Service released a statement confirming that the area surrounding the new feature would remain restricted until further notice. They also assured the public that there was no immediate danger but emphasized the importance of monitoring. Thermal drones, seismographs, and ground temperature sensors were recalibrated to track any new activity. Satellite images revealed fresh scars in the Earth's surface, light gray soil, blackened edges, and of course, the gleaming, otherworldly blue center. This wasn't the first time Yellowstone had revealed a new feature, but this one felt different. It wasn't just the color or the speed at which it formed. It was the location, the timing, and the intensity. Something beneath Yellowstone had stirred, and the Earth had responded. Now, the world is watching. Inside the engine, Yellowstone's hidden power. Yellowstone isn't just a scenic wonderland of bison herds and steaming rivers. Beneath its surface lies one of the most complex and volatile hydrothermal systems on Earth. At the heart of it all is a massive chamber of partially molten rock, magma, that radiates intense heat upward toward the Earth's crust. That heat, combined with water from rain and snowmelt seeping into the ground, creates a dynamic underground environment fueled by pressure, minerals, and volatile gases. This unique combination is what gives rise to Yellowstone's iconic features. Geysers erupt with towering jets of steam, hot springs swirl in mesmerizing colors, fumaroles hiss with scalding gas, and mud pots bubble with acidic fury. Each of these features forms as heat and pressure interact differently beneath the surface. When water heats slowly and finds a release channel, it becomes a pool. When it gets trapped and boils violently, it explodes as a geyser. When pressure escapes primarily through gas, we see fumaroles. And when the water mixes with acidic elements and clay, we get those bubbling mud pots. What makes Yellowstone exceptional is the sheer scale and variability of its geothermal system. The magma reservoir beneath the park is vast, spanning more than 50 kilometers, and it fuels more than 10,000 individual thermal features. This underground heat engine never sleeps. It's always shifting, always changing. The rock above the magma can rise or sink depending on changes in pressure, creating uplift or subsidence across the park. These subtle movements often go unnoticed, but sometimes they lead to surface fractures or cracks, creating pathways for superheated water to escape. When it does, new holes, vents, or pools can form within hours. That's what seems to have happened with the new blue pool. A buildup of thermal energy and water pressure, combined with a fracture in the crust, allowed the underground fluid to reach the surface suddenly. In an instant, a new feature was born, its heat and minerals coloring it in brilliant shades of blue and white. It's not an isolated event either. Over the decades, Yellowstone has birthed dozens of new pools, fumaroles, and thermal scars, each one telling a story of the shifting geological forces beneath. This hidden hydrothermal engine is both beautiful and dangerous. It's what makes Yellowstone the most studied geothermal field in the world. But it also makes every new feature, every plume of steam, every eruption of mud, every unexpected hole, a potential clue to what lies deeper. And for scientists monitoring the park, each of these signs matters. Understanding, mildly explosive, at Yellowstone. When scientists described the recent activity at Yellowstone as mildly explosive, it wasn't a casual label. In geological terms, even a mild explosion can represent a sudden and dramatic shift in subterranean conditions. The phrase doesn't mean it was harmless. It means it didn't register as a full volcanic eruption, but it involved enough force to fracture the Earth's crust and violently expel material to the surface. Yellowstone has a long history of such events. In fact, hydrothermal explosions are relatively common across the park's more volatile regions. One of the most notable examples occurred in 1989 when Porkchop Geyser erupted unexpectedly after years of dormancy, blasting rocks and debris over 30 feet into the air. The Norris Geyser Basin, where the new blue pool has formed, has seen even more recent turbulence. Steamboat Geyser, the world's tallest active geyser, has erupted over 40 times in a single year, a level of unrest that had not been recorded before the last decade. These explosions aren't driven by magma, but by trapped steam and gases. As rainwater or snowmelt filters into the ground, it seeps through fractures and heats up rapidly as it nears the magma chamber. When that superheated water turns to steam and becomes trapped beneath solid rock, it creates a pressure cooker. If the pressure isn't released gradually, it can rupture the overlying rock in a burst of force, sending debris flying and opening up new thermal features. That's what happened in this most recent event. A combination of rising heat, unstable pressure, and weak crust resulted in a sudden release. Fortunately, it occurred in a remote section of the park, away from visitor areas. But that doesn't make it any less significant. It's a geological wake-up call. Is this natural variation? Absolutely. Yellowstone is one of the most active geothermal areas on Earth, and new features appear regularly. But each one tells us something important. Each change is a signal from the planet's inner workings. And when the crust explodes, even mildly, scientists take notice. Because at Yellowstone, even a whisper from below can be the start of something much louder. The boiling heart of Yellowstone Norris Geyser Basin isn't just another stop on the Yellowstone map. It's the most unpredictable and geologically intense location in the entire park. Scientists have long referred to it as Yellowstone's boiling heart, a place where the Earth's internal energy rises dangerously close to the surface. What makes Norris so volatile is its direct connection to deep underground heat sources and fault lines that constantly shift the region's geological structure. Temperatures at Norris exceed those found in any other area of Yellowstone. Some vents and pools here reach over 200 degrees Fahrenheit. The ground hisses, pulses, and in some cases, even moves. Unlike the more stable Old Faithful area, Norris doesn't follow a predictable rhythm. It erupts suddenly, simmers unexpectedly, and sometimes shuts down entire zones without warning. At the center of this chaotic landscape is Steamboat Geyser, the world's tallest active geyser. In recent years, it has shattered its own eruption records, with towering blasts of water and steam reaching heights of up to 300 feet. From 2018 onward, Steamboat's activity increased dramatically, leading researchers to question whether the geyser was responding to deeper tectonic or magmatic forces. The new blue pool's appearance just a short distance from Steamboat adds another layer of mystery to an already unpredictable region. This isn't the first time Norris has surprised scientists. In 2003, the basin was temporarily closed after a sudden increase in ground temperature began melting asphalt and warping boardwalks. That same year, a brand new steam vent burst open just off the trail. In 2014, satellite imagery detected unusual ground uplift, prompting further investigations into possible magma movement beneath the basin. Each of these events offered clues, but none gave definitive answers. According to Dr. Jacob Lowenstern, former scientist in charge of the Yellowstone Volcano Observatory, Norris is where we expect change to happen. It's not unusual, but it is important. It reminds us that this landscape is alive. Still, theories persist. Some researchers believe these shifts could be signs of deep magma migration. Others argue that what we're seeing is surface-level hydrothermal instability with no connection to larger events. The truth, no one knows for certain. But every time Norris Geyser Basin reshapes itself, whether through a new pool, a steam explosion, or a shift in heat signatures, the world pays attention. Because if anything at Yellowstone is going to hint at what's coming next, it will probably happen here first. How scientists track Yellowstone's shifting landscape. Tracking Yellowstone's geothermal behavior requires more than a few temperature readings and a watchful eye. Scientists use a high-tech toolkit to monitor the park's every tremble, every plume of steam, and every change in the ground's surface. And with the recent discovery of the blue pool, this technology is proving more essential than ever. One of the most important tools in the field is satellite-based thermal imaging. These orbiting eyes in the sky allow scientists to detect subtle changes in surface temperature over time. By comparing satellite data from previous months, researchers were able to confirm that the area where the blue pool formed had experienced a rapid and localized temperature spike just days before the eruption. On the ground, teams use radar systems that penetrate the Earth's upper layers. Ground-penetrating radar can reveal voids, fractures, and pockets of pressurized steam long before they reach the surface. Combined with drone-based thermal cameras, these tools give scientists a 3D map of the ever-changing geothermal landscape in real time. Seismic monitoring adds another layer of understanding. Yellowstone is dotted with seismic stations that track earthquakes and tremors across the park. Many of these movements are tiny, too small for humans to feel, but they provide vital clues. A cluster of small quakes near Norris often signals that water, gas, or heat is moving through underground pathways. Back in 2018, this combination of tools helped identify an unusual bulge forming beneath the surface near Norris. The ground had risen by several inches in just a few months. That uplift coincided with increased geyser activity, including a record-breaking year for Steamboat. Although the cause was eventually linked to hydrothermal shifts rather than magma intrusion, it proved how effective modern tools are at decoding Yellowstone's secrets. In the case of the new blue pool, it was this same layered approach: satellites, radar, drones, and seismographs that confirmed the eruption's signature. And as Yellowstone continues to evolve, these tools will be our early warning system for whatever comes next. Yellowstone's shocking past and lessons learned. Yellowstone has always had a reputation for surprising even the most seasoned geologists. While the park's geothermal beauty attracts millions of visitors each year, its history is also marked by sudden changes and unexpected events that have reshaped both the landscape and the scientific understanding of what lies below. One of the most significant moments in the park's seismic history occurred in 1959, when the Hebgen Lake earthquake struck with a magnitude of 7.3. This powerful quake triggered massive landslides, reshaped river paths, and caused dramatic shifts in hydrothermal features. Geysers erupted erratically, some went silent, and new springs emerged overnight. It was a wake-up call that Yellowstone's geothermal systems could respond rapidly to deep geological stress. Fast forward to 2003, when a dramatic spike in surface temperatures in the Norris Geyser Basin forced park officials to close trails and restrict access. Asphalt on visitor paths began to bubble and deform, while boardwalks warped and cracked. In that same year, a hydrothermal explosion in the back basin created a new vent, releasing a violent plume of steam and gas. It was a powerful reminder that Yellowstone's danger isn't limited to hypothetical supervolcano eruptions. Its day-to-day activity carries real consequences. There have also been countless smaller events that unfolded without warning. Geysers that have been dormant for decades suddenly burst back to life. Hot pools drained and refilled overnight, shifting colors and temperatures in response to unseen changes beneath the surface. Each of these moments has added to the growing catalog of Yellowstone's behaviors. Compared to the past, the recent blue pool formation fits a familiar pattern. A sudden thermal shift, surface rupture, and the birth of a new hydrothermal feature. What's changed is our ability to detect it in real time and respond quickly. While the raw forces at work remain the same, our understanding, and our respect for the land's unpredictability, continues to evolve. Is Yellowstone waking up or just stretching? Whenever a new thermal event occurs at Yellowstone, the same question floods social media and news outlets. Is this the beginning of a supervolcano eruption? Is Yellowstone waking up after thousands of years of dormancy? These concerns may seem dramatic, but they reflect a deep-rooted fear that lies beneath the fascination with this incredible national park. The truth is, Yellowstone is always active. Its geothermal systems are constantly shifting, reacting to pressure, water flow, and heat from below. According to the United States Geological Survey, there is currently no evidence of any imminent eruption. The blue pool formation, while visually dramatic, is considered a natural part of the park's hydrothermal behavior. In their official statement, USGS scientists reiterated that Yellowstone remains under constant observation and that the activity seen in July was not unusual for the Norris Geyser Basin. Still, that doesn't stop public speculation. Videos claiming Yellowstone is cracking open rack up millions of views. The idea of a supervolcano explosion has become part of modern folklore, fueled by documentaries, disaster films, and ominous headlines. But scientists emphasize the importance of separating sensationalism from science. While a super eruption is possible in Yellowstone's distant future, there are no current signs pointing in that direction. Overhyping events like the blue pool discovery can create unnecessary panic and misinformation. That's why experts urge the public to rely on credible sources. In reality, what's happening at Yellowstone is exactly what it's been doing for thousands of years, changing, venting, erupting, and forming new thermal features. It's alive, but not alarming. In the meantime, park authorities have cordoned off the area surrounding the new pool to ensure visitor safety. Monitoring equipment has been recalibrated to focus on the region, and rangers are working closely with geologists to track ongoing developments. For now, the situation is under control. But in Yellowstone, being under control doesn't mean being predictable. That's what makes it both breathtaking and a little unsettling. What comes next in Yellowstone's story? The sudden appearance of a steaming blue pool in Yellowstone's volatile Norris Geyser Basin is more than just a fascinating visual. It's a vivid reminder that this ancient landscape is still writing its story, one seismic shift at a time. Beneath the surface, geothermal forces are constantly at work, reshaping the land, boiling water into steam, and creating entirely new features without warning. Scientists may not be raising alarms, but they are paying close attention. Every change, every rumble, every rising plume of gas adds another clue to the complex puzzle of Yellowstone's behavior. While the word eruption tends to stir fear, in this case, it reveals something deeper. Yellowstone is alive. Its heartbeat is measured in geyser eruptions, its breath in rising steam, and its thoughts in the mysterious features it leaves behind. The hidden blue pool is one of those clues, a quiet eruption of nature's artistry and power. So, what happens next? That's the question scientists are still asking. And it's the reason Yellowstone remains one of the most closely watched places on Earth. Because beneath its beauty lies something untamed. And every new discovery brings us closer to understanding the force that sleeps just beneath our feet.